Hi guys. Okay, so one of the things I like to do in this class is sort of tie things together throughout the semester. So a week or a little while ago, you read some papers. There's some jigsaw activity you did in reading scientific literature, and one of them was by Pacala and Sokolo. And buried in this article was this thing. This is sort of like, I think, a key nugget to that whole paper, which is over a 50-year period from when they did their study, they were visualizing that if we do a business as usual approach where every year we burn more and more carbon and emit that into the atmosphere, then the carbon emissions are going to go up like this. And on the vertical scale, we have gigatons of carbon per year. And they say climate change, bad, not sustainable. We're all going to die if we do that. We need to do something else. Well, so then they said, well, what would be the ideal amount of fossil fuel emissions over that 50-year period? And they drew this line here. And they said, blah, blah, blah. Stabilization is represented by a flat trajectory of fossil fuel emissions at 7 gigatons of carbon per year. So boy, it's so easy to just skip right over that. 7 gigatons, 14 gigatons, and we need to do something. And I have to stop there because I personally like to visualize information that's given to me, especially super important information upon which the fate of the planet relies. So I got hung up on this 7 gigatons of carbon per year. Also, in this class, I am exercising the part of your brain that does quantitative thinking. And I've been talking about this problem-solving method, the railroad track method, this 9-step method. And so I just, in this video, just wanted to give you a demonstration of an application of that. So if you're still struggling with that, if you're still learning, I hope you follow me through here. Follow me as I go through this problem, and I hope it just continues to reinforce the cognitive pathways that help you do this kind of problem solving. Okay, so this is what I did. I wanted to know what 7 gigatons of carbon per year was and how can I visualize it. So there's no what am I trying to figure out here? I just started thinking, imagining this. What is 7 gigatons of carbon per year? Well, a gigaton, GT is a gigaton. What is that? A ton, T-O-N-N-E, is a million grams. Okay, I'll express that in scientific notation. 1 times 10 to the 6. You should memorize that a million is 10 to the 6, just like 1,000 is 10 to the 3. Okay, so that's a ton, but I've got a gigaton. What's a gigaton? Gigaton is 1 times 10 to the 9, and that's a big number. That's a billion. So a gigaton is a million billion grams. That's certainly a big number. Sure sounds big. I prefer to express it in scientific notation, and this is how I figure that out. 7 gigatons is 7 times 10 raised to the 9 giga plus 6 million. 9 plus 6 grams. So that's 7 times 10 to the 15 grams carbon. Maybe I'm going a little too fast. I don't know. If you're uncertain about scientific notation, pause the video and go through this and make sure I did that right. Make sure you understand how I did that. All right, so I still don't know what the heck 7 times 10 to the 15 grams carbon is. I have no idea. That's not helpful for me to visualize what's going on. What is a gram of carbon? Well, so carbon, I hope you know, is a component of CO2. And when you're actually doing calculations like this, you have to look at what you're given. If they're talking about CO2 versus carbon, those have different numbers associated with them, densities. I won't go into that now. Anyway, it's not helpful to me to know that carbon is a component of CO2 because I can't visualize a gram of CO2 either. So what can I do? Well, I do know a little bit about chemistry, and I know that graphite is pure carbon. So is diamond. But I don't really have a lot of diamonds hanging around, but I've got pencils. Graphite is this black stuff inside a pencil. Okay, all right. So 7 gigatons of carbon is the same as 7 times 10 to the 15 grams of graphite. Okay, how am I going to visualize that? Well, let's see. I'll just say, I might say it again, I forget. what I want to do is convert 7 gigatons of carbon to a big chunk of graphite that I can visualize. That's what I did for this problem. And you might do something else, but this is my way of visualizing problems, and it's going to require the kind of problem solving that we've been doing. Okay, so what's graphite's density? I'm pretty sure I need to know that, and so I looked it up on Wikipedia, and Wikipedia, of course, gives me a range. You know, graphite, I guess there's different kinds of graphite, and it ranges between 2.09 and 2.23 grams per cubic centimeter. A cubic centimeter, a centimeter that way, a centimeter that way, and a centimeter that way. A cube of a centimeter cube of graphite is going to weigh 2.09 grams or 2.23 or somewhere in between there. I'm going to go with 2.09 grams as I go along. So I'm going to rephrase the question. 7 gigatons of carbon is the hypothetical target global annual carbon emission, which is okay for Earth, I guess, according to those guys. All right, 7, that's okay. So what size of a cube of graphite would that be? How big a cube of graphite is that? Why am I doing this? I'm just curious. I don't have to. I'm just curious. All right, let's figure out how big that cube of graphite would be. So what do I want? I want cubic miles. Okay, remember the first step of the 9-step method is like, what are the units in your answer? It's going to be cubic miles or cubic miles per year, cubic miles of graphite per year. And so, okay, the second step is to guess. Oh, 7 gigaton. I can't guess. I don't have a guesstimate, but you're forcing me to have a guesstimate. Yes, I am. It's the second step. Just do it. So I'm like, I don't know. Just pull a number out of a hat. A cube that's 10 miles by 10 miles by 10 miles, right? I don't know. But wait a minute. 10 miles by 10 miles. From here to the other side of Eureka is about 10 miles. And so that's cool. And I can measure an area of land 10 by 10, pretty good. But the problem is going up 10 miles, I'm leaving the atmosphere. A mile is 5,000 feet and change. So 10 is 50,000 feet. Aircraft, like commercial jetliners, fly at 40,000 feet. That's a huge, big chunk. It's what's Mount Everest, 20,000 feet. So 10 miles. So this is taller than Mount Everest. So, okay, I'm going to revise my estimate down. Instead of, say, 10 by 10, I'm just going to go with 5 by 5. All right, so that's going to be my guess. And that, when you guess, that's sort of the level of guessing you do. You don't know, but you just, you guess. You use your best effort, okay, and knowing that it's going to be wrong. That's okay. It's a guess. So again, what do I want? Cubic miles of graphite per year. And then what do I have? Not a lot, but I thought about some stuff and I went and got it. So although I say the 9-step method is designed so that you don't have to think, sometimes you actually do have to think just in terms of what units do I need to answer this problem? What unit conversions do I need so that they cancel out and give me what I want? So I did have 7 gigatons of graphite per year, and I do have the density of graphite, 1 cubic centimeter of graphite per 2.09 grams. You can flip these backwards. It's the same thing as 2.09 grams of graphite is the same as 1 cubic centimeter of graphite. You can flip them upside down. Any equivalency equals 1 mathematically, theoretically, and so you can always flip 1 upside down. 9 over 9 is the same as 9 over 9. Okay. Then I got some unit conversions. There's 1,000,000 grams per ton. Why did I do that? Because I'm given grams. I know I'm going to have to go to tons, so I just went and found that. I also know I've got gigatons, so I figured out the conversion between gigatons and tons, and maybe I could have done grams per gigaton. That would have been shorter. Could have done that, but I don't have to. I'm going to, 1 cubic centimeter of graphite. Yeah, I want miles, right? I want cubic miles of graphite, and I'm given a unit of measurement centimeters. So I'm going to have to convert from centimeters to miles, but I'm going to do a 2-step process. I know that there's centimeters to cubic meters. I just I Googled how many cubic centimeters in a meter, because I like meters. And then I went, how many cubic meters in a cubic mile? And I Googled that and I got that. So I think I have everything here, and I'm going fast here, and you're wondering, like, why did he go and get these things? you could actually do this your own way and do it differently, but the main thing is you got to go out and grab the units you need to cancel each other out to give you what you want, cubic miles per year. And that's what I did. Then it's just sticking it in the railroad track formula. Now, I've noticed that many people have trouble at this phase. They're really struggling. I don't know, you're trained to use parentheses or trained to do iterative processes instead of this. Guys, please do it this way. Look what I did. I wanted cubic miles of graphite, and I looked around here for where cubic miles is, and I found it here. And since I know I want that in my answer, I stick it in first. 1 cubic mile over, oops. Oh, that's meter. Oh, yeah, here it is. Yeah, 1 cubic mile. I flipped it upside down to put miles on top because I want miles on top to get the answer. So I put cubic miles, and I put this thing on the bottom. And then I'm like, I'm going to need to get rid of this cubic meters. Do I have cubic meters somewhere? Yes, I do. So I stuck this in. 1 cubic meter over that. Put it there. Now I have cubic centimeters. I'm going to have to cancel that out. Where am I going to get that? Right here. Stuck that in. Put that in, and everything's canceling. But now I have grams on the bottom. I want to get rid of grams. So where do I get rid of grams? This one here. Stick that in. Now I've got tons. So I found, let's see, 1 times 10 to the 9. Where is that? 1 times 10. Here, 1 times 10 to the 9 tons per gigaton. Stick that in. Tons will cancel out. I've got gigatons. I put 7 gigatons graphite over here. And voila, years are on the bottom. And I get cubic miles of graphite per year. Cool. So this requires some jigsaw puzzle kind of stuff. You've got to flip the, or what's it? I don't know. There's a game where you make things fit together. So you're free to flip things up and down till the units cancel and give you what you want. And also, if you can't do it, then it probably means you have something in here you don't need, or you need something that you don't have. And that's where some thinking comes in handy. You have to figure out what that is and what to do about that. That can be a little tricky. So now I'm all done except for the math. And so what you do is you multiply everything on top together, and then you separately multiply everything on the bottom together, and then you divide the top by the bottom. And here's what I did. This was the top, and this is the bottom. The bottom is a little bit complicated because you have some scientific notation in here. And so when you're multiplying scientific notation, remember you multiply the numbers. If you're multiplying, you multiply the numbers, which is the first part, and then you add the exponents, which is what I've done here. I have 2.9 in there. 2.9 times that simplifies to 2.9 times that. I put that in parentheses, times 10 to the 15, which is 9 and 6 is 15. Okay. Cool. And by the way, 10 to the 15, they cancel out wonderfully. And so I get cubic miles per year, and I get 7 over about 8. So, hey, I'm getting just shy of 1 cubic mile, which is like, wow, now I'm really happy because I knew my answer should be somewhere around here. I guessed 5. It's not 50 or 500 or 1/500th. I'm pretty close. I'm happy. By the way, I want to know, this is like what is 0.8 of a cubic mile? Well, that's a cube. That's this dimension, and this dimension multiplied together. And really, since it's a cube, all sides are the same. I'd like to know the length of that side so I can walk it on the street. So I take the cube root of 0.8, and that is just shy of a mile. Oh yeah, sig figs. I'm not done. Sig figs and scientific notation. Actually, sig figs. Great question. Which of these are measurements? 7 gigatons of graphite were given to me by Sokolow and Pakala, and one has to ask oneself: is that a measurement or some God-given number? I'm going to go with measurement because they're basing their, I'm assuming they're basing their 7 gigatons per year based on measurements of atmosphere and emissions and our understanding of climate change. The 2.09 grams per graphite, that's a measurement. Yes, someone actually measured graphite and how, took a perfect cubic centimeter and weighed it. Oh, by the way, this is a piece of coal. It's about cubic centimeter, I guess. This is what a cubic centimeter of carbon looks like. This is coal, not graphite, but they're about the same thing. Got that from the side of a railroad track in Virginia, where railroad cars go by the miles full of coal. Uh, Grams per ton is a God-given number. Tons per gigaton is a God-given number. Cubic miles per cubic centimeters, that's a God-given definition. And let's see, what's this? 4.168 cubic meters per cubic mile. That's the relationship of cubic meters to miles is a perfect number. I'm assuming if it's not perfect, it's been measured so well that it's got so many digits, it's never going to determine your level of significance. So we end up with 1, or well, our choices are 1 or 3. We go with a smaller one, 1. So I'm going to round my 0.8 to, or my 0.9 to 1 mile. So it's a cube of graphite that's conveniently 1 mile by 1 mile by 1 mile. So really? So that means these guys think if we take up the equivalent of a cube of graphite that's 1 mile on a side and convert it into CO2, burn it, and stick it up in the atmosphere, that's okay. All right, if they say so. Seems weird to me. What is it? My estimate was 5. So what did we just do? Okay, I'm sort of working that through. We're done. Okay, I did the problem, but I'm still like pondering. I'm trying to visualize this. And one of the things I want to show you is this is Arcata. I want to know what a cubic mile is. And so I go to Google Earth, and they have this thing. It's one of the choices up here. There's a ruler, I think, and I'm measuring a line. And I know that this is the College Creek dorms in that field right there. And so I'm just going to measure a mile, and it's reading off. There's a mile right there. And where is that? That's at the end of Sunset Avenue. So if you walk right down, I think that's 14th Street. And if you could keep going, I think you have to take a bridge or something. I don't know. Yeah. And anyway, keep going. Am I right? No. It's in the Sunset neighborhood anyway. And that's a mile. Okay. And so then I'd have to go a mile the other direction, and also a mile up in the air. And in Google Earth on the bottom right, I don't know if you can see this, there's an eye altitude. I'm at 6,000 feet. So I would be just above that cube of graphite. That would be a big cube of graphite. It's interesting that humans can, with their steam shovels and dynamite and trucks and trains and stuff, can take that. That's how much humans take out of the ground and burn and put into the air. All right, I'll leave you to speculate and visualize. I just, most importantly, wanted to just show you a demonstration of what you can do with this back of the envelope estimation and problem solving. 9-step method, railroad track. It works sometimes. Okay, thank you. Bye.